Here, everything is fine.
Yes, everything fine. Thank you.
Okay, perfect. So in case of any question, feel free to interrupt me. So, and regarding the audience, I would like to have it in an interactive way. So in case of any question that arises, just feel free to like interrupt me and just like let's answer because like I don't want to just basically talk and just like wait for the questions because I know that sometimes the questions diminish and it's better to just basically answer them on the fly. I believe that this is kind of more efficient and it's like more informative. Just as a heads up. Uh, yeah.
I guess
So
we
yeah,
can start. Yes, I mean, I chatted with the other team and like also they said
yeah.
they're well, yeah. Thank you.
If
Thank you.
everything is fine, then I can start slowly. So uh, today I'm Redzhep Mehmedov Redzhebov. Today I'm going to talk about some applications in the AI, especially in the computer vision field, that when it comes to using the simulation or synthetic data to be able to just basically make your applications better, or just like when you have like little amount of or like inaccessible amount of data, and then you just basically leverage them. So first of all, who am I? I'm Redzhep Mehmedov. I'm a data engineer, and I'm working on basically mainly industrial problems and making them scalable and maintainable for longer than 8 years. My main expertise is computer vision, and or my examples today are going to be focusing on computer vision and deep learning. I'm also like basically like working on the unsupervised learning, reinforcement learning, computational algorithmic optimization. So let's start. So what am I going to talk about? Why simulation data, the facts of real to sim, sim to real, how to do it. I will give you a couple of examples, and I would like to basically also mention the mindset that you should have or that you can have in the beginning to make it happen or leverage that, because like it's a quite how to say the gray area topic that is like in some cases you believe that you can use it and it doesn't work. In some cases you believe that it's not going to work and it works. Then eventually we will end up with a Q&A. So the first one, why synthetic data? Like finding the real world data is like it's always a problem, right? Like especially the data scientists and data engineers will understand that it's like when you start the process, it's like, okay, I want to make a predictive model that basically does something, finds basically the hot dogs or not hot dogs or dogs, cats, whatever, but we don't have this data, right? And how are we going to resolve it? Like what's the solution? It's like, and you have to collect data, and the real data is not available for every application, especially in your industry. They have lots of NDAs, lots of disclosures, this lots of problems. So it's not that easy to generate that data. It's not that easy to generate the capture the data. Additionally, like what's hard, the problem too is the annotations, right? So you want to have a predictive model which basically does something. And you to be able to do that, you need labels that basically describes what you want to predict. And this is quite a how to say like expensive and time consuming and it's a concept, it's a process with a lots of concerns because at the end like human in the loop and they can fail because like after like basically reviewing I don't know 1,000 images, like after you become derp and you become less focused, and as you appreciate like it causes like lots of issues and failures, and this basically influences your predictive model at the end. So basically you have to loop through and it's just like more time consuming, and of course like time is money and the money is wasted. The third one is like, okay, you have a predictive model, but you want more data. You need more data. You need to find edge cases and etc. There are many platforms that resolves that, but it's like finding data, accessing the data. It's not that easy. What if you can just basically generate these examples to just basically mitigate it a little to be able to, reach your goals? For example, in cases like you in your initial data set, you never had an overexposure, eliminated or reflected data, which you basically encountered during your production. So you have to just basically to be able to use either very limited amount of data that you just basically hardly grasp in the case that it failed, or you can just basically find a way to just basically generate many of them in an algorithmic way and just like fine tune your model. So these are like main problems, and these are big problems if you're really, really focusing on industrial applications, because your predictive model has to be very, very accurate, because any error will cause like basically like a problem, and this problem will be translated to money after all, and everybody wants to make a profit, right? So can we really use the synthetic data to make something work? Here are some examples. In the bottom, they are real examples, and in the top, like they are synthetic data examples from a couple of like pipelines, of course. And if you look at them, it's like there is a significant difference. But can we really make it use? Yes. But we have to listen Yoda here. Like this, like I will try to translate because he likes to speak in a different way, right? So he literally says that instead of trying to solve things in a very direct manner, think about how you can just basically divide it into multiple stages and just like think about how you can connect these stages. So this is basically can stay very abstract at this very moment, but it will be clear the more I continue. So let's first embrace the fact we can solve every problem using simulation data. This is not possible, unfortunately. But as you can see, like we can get some help from the simulations, right? The simulation or synthetic data. How are we going to do that? So first of all, like there will be always obvious example of differences between simulation and the real world data. As you can see, like it's basically like one is like a cartoon. Like you cannot just basically reflect everything as much as you want. You will always forget something and everything. And it's like it will be obvious. With your bare naked eyes, you will be able to distinguish most of the time, unless it has been like a big project that just basically use lots of technologies, which are very, very expensive. So how are we going to do that? So first of all, it's always good to push the quality of your simulations or the synthetic data as much as you can. The money that you spend on it will basically pay off. The time you spend on it will pay off because it's a one-time chunk of a work that will basically just like allow you to generate more and more and more data. And you won't have lots of like basically big updates when it's needed. The second one, like again, like Yoda said, avoid direct solutions. Because if you're using simulation data, these basically significant differences are ready to just basically punish you. Any reflection, any basically indefinite line, especially in the computer vision, will just basically like trick your predictive model and you won't be able to get the result that you want. So this is like basically like I marked it with red on purpose because this needs to be like paid attention. And the next one is like, if you can access there a bit of real data, why don't you use it? Why don't we mix it? Why don't we just basically leverage from that? Still, it's like data is a data, right? And sometimes you just don't need to work on this like bare image level, but you need to work on the level of the like basically labels. This is a kind of making things simpler because the labeling process is a bit like, abstracting your real world data to like another level. And it's like you can have it in the same format from the simulation data. The real simulation data is different than the real world images, but your real world annotated semantic segmentation images are almost identical to the real world images. So it's like in that case, it's not that easy to distinguish. So this can be just like a trick. And I will just basically show you the one example about it. And maybe like in case of like that, how about like basically if you have a case and you have an environment to just deploy this predictive model, right? And what if like basically instead of working on the simulation level, what if you just basically try to restrict it or just update it in a way that the simulation data will be easily obtained and you will be able to just, generate decent amount of data for a very simpler case. It's like basically environment simplification, which is always a good point to just basically use in industrial applications, if you know what I mean. Okay. So I will start with examples because these examples I think will help you better. So here, this is the direct, fully simulated data example. So we had this case of basically grasping the candy boxes. I don't know if they're visible from the table and with the robot arms. So it's kind of robotics project and like computer vision guided robotics project. And we needed to localize these objects in the 6D pose, which means it's like translation plus orientation. So to be able to do that, it's like we wanted to generate data. And it's like it was one of our, for example, core points, like core strengths, but we needed to prove that. First of all, we just basically started, like we looked at the object. And when we look at the object, the candy box it's not such a complex object. So it's like, we just thought, can we just basically transform it to some kind of CAD model and just put it into some kind of simulation platform like NVIDIA Omniverse or Unity and just basically like model it there and just try to collect data. And we started with that. And initially, like we just said, okay, the direct solution is basically finding every object in the scene in the 6D pose. Like it's quite complicated because the background changes and everything. How are we going to solve it? So we just decided to divide this into two parts. First, the 2D object detector, you can just imagine anything, YOLO, SSD, whatever. And just basically we train this object detector only on the simulation data. This basically will allow us to just basically get only the region of the candy boxes in the scene and we can just basically crop them out. So we can isolate the entire scene, and we can just basically focus on simpler cases, because when you zoom out, it's easier to see like where it's located, right? So we can just basically do this 60 pose estimation according to what we see, right? And then afterwards, it's like, then we decided to basically work on the 60 pose estimation, which is another deep learning model that just basically tries to translate these like features for each object. And it's like already simplified, so we can generate enormous amount of data, right? And just basically we train this on. And it's like basically the results we got is like, as you can see, they worked out in the real data. So our pipeline is basically like just training two different types of model, only simulated data, by just simplifying to achieve the realistic results. And we were able to just basically perform the real-time grasping and just placing it somewhere else through that. Like I said, if there is any question, I would like to know, and I would like to hear. Otherwise, I will switch to the next one.
There is actually one question since you mentioned it.
Yeah.
Asked by Evgenia. What is reality in your context? Could you explain?
I would like to say it's like basically like that's a very philosophical question, right? Like it's like I will just like to answer it in a simple way. When you open the camera, like whatever you see in the camera, right? So this is what you see. So this is the real world example, actually, real world data. This is what I will say, but I would like to know a bit more like context in terms of the questioning the reality.
Okay, so let's keep your plan, and then end of it we can discuss further.
Yeah, if it arises, I would like to answer again.
Follow-up question. Yeah.
All right. Okay, the next one is like the domain transfer, right? So basically we have this real image, right? It's like basically the rabbit, and we have this case. But we cannot collect this crazy amount of rabbit objects as like basically images of rabbits, because they're moving fast, right? Like something happens and you don't access to this. So what happens is like basically like, but you can create some kind of like, this is some kind of exemplary one, and I'm under NDA, so I cannot share the real object, but we tested out on some industrial applications. So rabbit can be just like any industrial weird looking object that just like has a weird colors. And what we do is like basically we simulate the rabbit in the simulation environment, and we collect again enormous amount of data, and we have an object detector. But we know that this time like basically, or the object detector is incapable of doing that because of the variation, the speed and everything. But what we could do is basically like instead of just basically like we can collect maybe like X amount of data. We had this like access to the like little amount of data or decent amount of data, but instead of annotating, what we did is basically we just got these images. Instead of annotating them, we just basically like trained some kind of unsupervised domain transfer model that just basically tries to just basically bridge the gap between the simulation and the real world, and just basically makes, when you give this like real world image, it just tries to make output something like a cartoon, which is like basically what we simulated there, or other way around. When we give a simulated image, it just tries to give the real world output. As you can appreciate, this like basically the details of the real world is just like basically crazy, and it's not that easy to match. But the other way around is like simpler. So it's like, and in that case, it's like basically we have this animal to cartoon model, which basically said whenever we give a real world image, it just basically outputs some kind of cartoon looking like simulation output like image. And what we can do in the simulation data, like I said, we can annotate everything very fast because it's just an algorithmic thing, and we already know where the objects are and everything. So we can just generate, we just basically trained a very quick object detector just for the rabbits, and it only works on the simulated data. It really fails on the real data, but once we add this basically the translation module, then it just started to basically like see something similar to what it is like basically fit to, and it just basically traces back, and it can just like accurately or semi-accurately predicts the position of the rabbits. And this basically allows us to just like create a data, just to create a realistic annotation, quick annotations from the data that we collected, you know. And then we don't need to just spend time and everything. That just basically, it's about the correction of the data. Okay, another question. Anything else here I would like to hear? I believe the silence means no. So I will go to the next example. Okay, this annotation level that I mentioned. So exactly like how I mentioned. So like image to image level, like the basically image level operations, sometimes like they're always tricky because it's hard to represent, like, and it's like there will be always significant differences. But in the annotation level, for example, in this case, you can just consider them like semantic segmentation, which basically this just basically in each region it describes that what object is, and it's like colored in a different way. So our goal is basically like here is like we have a frontal camera view, which we see from like we are seeing like more eyes, and there is a bird eye view, which is like basically you're flying a drone and you're seeing from the top. And in the real world, it's like simultaneously collecting this kind of data, even if you have the ability to collect this basically enormous amount of data, like annotate this enormous amount of data, it's very hard to collect because synchronization of this data and everything is just like quite a tedious work. And what you can do, but in simulation, again, it's like you can just simulate it, and it's like it's completely algorithmic. So a week of like development, tuning, and everything, this you can just basically get perfectly paired frontal camera and the world view camera annotations, which is basically good because you can just basically have a frontal camera view in your like from the real world data. Okay, that's fine, perfect. And you can just run your own supervised model that has been trained on the real world annotations. Totally fine. You span data, everything. But the converting into the bird eye view is expensive and it's a very tedious work. And it's like people are using like basically the camera intrinsics to make it happen and everything, but it's always like leading you a bit of inaccuracy and some spikes. And to be able to mitigate that, you're just constantly tuning those parameters. But if you can have a smart logic, like what we did, like POV to BEV, that's basically just like basically allows you to transform that. And in that case, it's like, since it's like very perfect top down, you can estimate the distances of each object from that one. The whole thing, the whole concept becomes some kind of like top down 2D game. And this is quite a common approach in the field of like self-driving car or any navigation task. So this is quite an interesting one. This hasn't happened recently, and we're still working on that. But this is like quite a nice example of like using the simulation data to make something happen and work in the real world. I will come to the mindset, the Zen of real to sim, sim to real, whatever, like lots of things. But again, if there is no question, I believe again, silence means no. Okay, so what kind of mindset do we need to be able to make it happen? So we shouldn't think about, again, direct stuff. Just divide your problems into smaller ones and conquer them. Just like basically like merge them slowly. Like think about how you can connect them, how you can simplify these problems into how you can simplify your complex problems into smaller one. So you can just basically like connect them and you will be solving easy problems at each step. You know, it's pretty much engineering. Then of course the simplification, right? Then it's just like basically once it's simplified, it's easier to solve and it's easier to collect the data. Of course, the last one is the most important one. Actually, the first three ones that focuses on the main concept. That's like basically simplification, dividing, and it's like avoiding this basically mindset that just to solve everything at once. The last one is basically if you can just change something in the simulation, if you just basically can afford a bit more, hire some kind of realistic 3D engineers who can just basically develop these CAD models, or who can just basically, I don't know, like provide something high quality that you can just use anytime. Don't just basically avoid this option and just go for it, because this will pay off right away. The closer you are to the reality, the real world, the real examples, when you look at them, it's like from your perception, the closer your model will be closer, and it will be easier for your model to just be basically understand the real features that needs to grasp to be able to make the prediction in the way that you're supposed to expect, you know. And of course, I forgot to mention here, it's like if you can simplify your fields, which basically I forgot to mention here, instead of like basically, as you can see in this example, like we have two tables and everything. We had a trick actually to make it better. Like instead of like basically focusing on the full scene, the camera has a very big field of view. We just basically also perform that table detection, which is easier, right? Like it's like very specific and simple object, and just basically focused on the table and run the detector on that. So, and this is a very good one. Another approach was like basically this, like we, instead of training the detector before that, we just basically zoomed the camera to the table to just see if it's going to work. And this worked out. And we were like, okay, first table detection, then candy box detection, then finally 60 pose estimation and the final projection and everything. And we know everything. So these are the tricks or the mindset that I would like to just basically tell you. It's like these are my, of course, opinions. There is more, of course, and I'm always open to more recommendations, but this is pretty much it. And thank you for your attention. And I would like to hear more questions if there is.
Thank you. Since we have questions and time, we can discuss. Actually, even Evgeny, you can raise by verbally, like a.
Yeah, I would like to hear.
Okay, maybe he's not. Okay, let me raise this question. First question. Okay, yeah.
I don't have any questions. I just had an answer actually to Sergey question because I think Sergey, I'm not sure.
My bad, Sergey, Evgeny. I'm sorry.
Okay.
Yes, no problem.
Okay. So thank you then. I guess yes, all question replied, but of course.
But maybe we can discuss this topic of using fake data generation techniques for more structured data, like especially customer data that can be strongly connected, but these relations are more explicit, and there are a lot of assumptions that we sort of can formally validate such data, but on the other hand, we have to adhere to these assumptions when we generate fake data.
Exactly. So like basically, especially my first claim was like basically, can we solve every problem or is it possible to do it? Like it's always maybe actually. Yes, you can leverage from that, but it's a bit of like sometimes it works, sometimes it doesn't work because you cannot see some problems that just basically can arise when you're trying to predict. It's like you don't see some textural problems or background problems, or you don't pay attention to that object is like reflective that can just basically cause lots of elimination. So this is like very, very important. So basically the simulation applications, like when you use it, when you want to use simulation or synthetic data, it doesn't mean that it's going to work no matter what. It's a bit experimental. So according to your first experimentation, that just basically gives you some sort of an output, then you can just take a decision and push for it. So this needs to be controlled. Like basically taking the leap right away to make something happen is not a good way to see that. This is something I must add into the Zen of Python, Zen of real to sim to real, whatever. On the other hand, it's like, yeah, that's true actually. Like currently, for example, on the projects that I'm working on, it's like basically we already always have some kind of separate how to say the logic that just basically is ready for getting a simulation data. So basically, like we always have the real world data part and it's like simulation data part. And in companies like we're just basically aiming to do that, I will recommend the same. I hope this answered the question.
Yes, partially. Just interested, is there some maybe recommended best practices for structured data generation? I mean, structured and connected data generation when we don't have connections, I mean, between in our path, but we have these connections in the data that we not only generate the unstructured data, but we generate data with some shape. I would say when connections are expressed as a shape, not visual, but let's say as some rules, etc.
Okay. So like it's basically like the
Here we are
structure
speaking
of the
about
data
images,
set.
and in image, yes, we have a shape, but it is basically just somebody draws a shape. But now somebody draws, of course, somebody draws an image diagram, but this image expresses additional. How can I say? This image expresses some patterns, but here we don't write these patterns explicitly. We simply imply them. In this image, they actually are implied first and written as rules, and then we only generate diagram by the description. And how can we feed basically this description into our model to generate fake data for our description?
Okay, so like basically this model generation process is actually hands-on engineering process. So this basically is like basically you explain what you want as some kind of like as a scene, right? Like You say, I want to have like this basically for example, I will talk about the object detector. You say that I would like to have this images, it's a set of images that randomizes the position of the object. Alongside, I would like to have, for example, bounding box information. Alongside, I would like to have, for example, like it's kind of encapsulated in a file or a CSV file or something like this. Depends on how you are going to deal with in the data engineering side or the model feeding side. And alongside this, like basically whatever you want to eat.
Actually, Sergey commented that relationships reflect certain multi-dimensional correlations in his situation.
Exactly. Oh yeah, so it's like you mean it's like basically okay, yeah, fair enough. So is this
Sorry.
answering your question again?
Probably, I'm not sure.
Okay. I mean, it's pretty much, it's just like these dimensions is like basically first one is in the image level. So I would like to just basically tell you that it's like pixel level, these first bounding boxes, these small rectangular things. Then the second one, it's just basically like visualization of the 6D pose estimation, which is basically kind of, how can I say, the relative position of the object according to the camera. So you have an object that the camera is here, the object is here, and you just basically like relative position of this object, like basically, or position and orientation according to this camera. And then you just basically try to estimate this accordingly. Is this clear?
Yes, I understand. I think maybe for later discussion.
Thank you. Yeah.
Yeah.
Thanks a lot. And still, like we have around 5 minutes. You can raise if no question.
Any questions?
I want to ask you. I guess in your pipeline there are steps that you are also generating fake data to implement your steps. And I mean, currently I'm working some, let's say, LLM project. We are kind of given some structure to AWS Bedrock, saying in that JSON format generate this data and so on. So actually we are restricting the output format. But when it comes to image, like are you restricting the output in the more like image level or some mathematical this metrics calculation level? You are saying that it should be in the number of these pixels and the level of blackness and so on. That's
so yeah, here is the thing. So like when you know the case, it's like basically all current simulated data or synthetic data generation is basically trying to fit to the real world camera spec. So if you are going to use in the real application, if you're aiming to use like full HD images, then we are trying to just basically do also full HD captures in the simulation side. So in case of any discrepancy, we're trying to eliminate any potential discrepancy in that regards. And in terms of, for example, the data quality, blur, and everything, we're just also trying to simulate like almost like we are trying to just basically make it close to the real application. This is one of the main like efforts that you put in actually while you're working on, and you're just basically reviewing the data accordingly.
okay.
Is this answering your question?
Yes. Thank you. Gotcha. So I believe there is no question, and thanks a lot. It was very thoughtful, and I believe it helped also our people, and it was some uncommon topic at this from our today talks, and we are happy to see you, and hopefully we'll see you again. Thanks a lot. Yeah.
It was a pleasure of mine, and anybody feel free to connect to me and discuss these topics more further. And it was a pleasure of mine. Thank you for organizing this event.
Thank you. Let's